Hi, let's solve some previous year gate problems from the chapter Theories of Failures. The first question is, which one of the following is not correct? The first statement is intermediate principal stress is ignored when applying the maximum principal stress theory. Yes, it is correct. In the maximum principal stress theory, we equate the maximum principal stress to the yield point stress, and we ignore the intermediate principal stress. The second option is the maximum shear stress theory gives the most accurate results among all the failure theories. No, this is not the correct statement because it depends upon what the material is. If the material is brittle, we use the maximum principal stress theory. If it is ductile, the von Mises theory gives the very conservative result. So this statement is not correct. And let's see the third option and fourth option also. As per the maximum strain energy theory, failure occurs when the strain energy per unit volume exceeds the critical value. Yes, this is correct. And as per the maximum distortion energy theory, that is von Mises theory, failure occurs when the distortion energy per unit volume exceeds the critical value. This is also correct. So option B is not correct, and this is our answer. Next question. A shaft is subjected to pure torsional moment. The maximum shear stress developed in the shaft is 100 megapascal. Okay, so it is subjected to pure torsional moment. That is, this is the key word. So when you draw the Mohr's circle for this state of stress, this will be the Mohr's circle. Okay, this is tau sigma. So this will be sigma 1 and this is sigma 2. The principal stresses, sigma 1 is equal to minus of sigma 2. Their magnitude is same, but there will be a negative sign with sigma 2, and the value will be equal to the radius of the Mohr's circle, and whose value is equal to tau max, that is maximum shear stress developed, which is this point here, and which is equal to 100 megapascal. So tau max is equal to 100 megapascal. Okay, the yield and ultimate strengths of the shaft material in tension are also given. The factor of safety using maximum distortion energy theory is. Okay, so in this video what you will see that most of the questions are from the von Mises theory or the Tresca's theory. So please be careful. Please prepare these two theories very thoroughly. I mean, generally the questions are asked on these theories. So we have to find the factor of safety using von Mises theory. So according to von Mises theory, we have our equation, that is sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 whole square should be less than equal to twice of SYT by n whole square. SYT is what? SYT is the yield strength of the material in tension. This is SYT, and n is the factor of safety that we have to find out. Okay, so this is a biaxial state of stress, so that implies sigma 3 is 0. Okay, and sigma 1 is 100 megapascal, sigma 2 is minus 100 megapascal, so this is minus 100 square plus sigma 2 is minus 100 square plus sigma 3 is 0, so this is again minus 100 square, should be less than equal to twice of SYT is yield strength of the shaft material, which is 300 megapascal by n whole square. So this is equal to 200 square plus 100 square plus 100 square. For limiting case, I will put a equal to sign, 300 square by n square. Okay, so when you solve this, n comes out to be 1.732. okay, according to von Mises theory, 1.732. okay, let's move on to the next question. So the question is, which one of the following is the most conservative fatigue failure criterion? Keyword most conservative. Okay, this is the keyword. So the options are Soderbergh, Modified Goodman, ASME elliptic, and Gerber's parabola. So when a component is subjected to fluctuating stresses, there is mean stress as well as amplitude stress, that is variable stress, and it has been observed that the mean stress component has an effect on fatigue failure when it is present in combination with the variable stress. Okay, and so when this component is subjected to both mean stress and variable stress, the actual failure occurs at different scattered points, that as shown in the figure that I'll be drawing right now. So like for this for this graph, we draw a graph between the amplitude stress and the mean stress, and this is sigma ut, this is sigma y. Sigma ut is ultimate tensile strength, and sigma y is yield strength. Okay, and पॉज कर यार, दोबारा करना है ये क्वेश्चन, यहाँ से दोबारा करूँगा ये क्वेश्चन. So the question is, which one of the following is the most conservative fatigue failure criterion? Okay, so the keyword is conservative fatigue failure criterion. Okay, the options are Soderbergh's criteria, Modified Goodman's, ASME elliptic, and Gerber's parabola. So when a component is subjected to fluctuating stresses, there is mean as well as amplitude stress, this we know, and it has been observed that the mean stress component has an effect on fatigue failure when it is present in combination with the variable stress, that is the alternating component, and when the component is subjected to both the component of these stresses, that is mean stress and variable stress, the actual failure occurs at different scattered points, and from those points we actually draw a border which divides the zone into safe zone and failure zone. And the criterias that we have studied for this are Gerber's parabola, Soderbergh's line, and Goodman's line. And there is one more criteria, failure criteria, given by ASME, that is American Society of Mechanical Engineers, ASME elliptic. Okay, so if we draw I'm not taking the answer. So if we draw this a graph between the amplitude stress and mean stress, this is the amplitude stress, this is yield stress, this is ultimate stress. So this is actually a straight line. Okay, it is a bit difficult to draw here. This is a straight line, and this is also a straight line. It's very difficult to draw here. I hope you get my point. This is a straight line. Okay, and this is the parabola. This is our Gerber's parabola. This is the Gerber's parabola. Okay, this is Goodman's line, and this is Soderbergh's line. Okay, and the ASME elliptic is given by this equation. Sigma m is sigma mean stress, sigma is variable stress, sigma y is yield stress, and sigma e is endurance stress. Okay, this is the ASME elliptic equation. Okay, so if a point lies here and we are inspecting it with a Gerber's parabola, that means the material will fail, because this is the failure zone for Gerber's parabola and this is the safe zone for Gerber's parabola. Similarly, for Goodman's line, only this portion, this triangular portion will be the safe portion, and out, and the point lying here, that is beyond this line, will be the failure region. Okay, so the Soderberg line is actually the most conservative fatigue failure criteria. Okay, so option A is our answer. Next question. A machine element is subjected to, यार pause करे यार, क्या यार, यहाँ से एक लाइन दोबारा बोल रहा हूँ, वो इंक्लूड करनी है. So the Soderberg line is a more conservative failure criteria, and there is no need to consider even yielding in this case. Okay, so this is the most conservative failure criteria. Okay, next question. A machine element is subjected to the following biaxial state of stress. The state of stress is given if the shear strength of the material is 100 megapascal. The factor of safety as per Tresca's maximum shear stress theory is. Okay, so according to Tresca's maximum shear stress theory, larger of sigma 1 minus sigma 2 by 2 mod, sigma 2 minus sigma 3 by 2 mod, sigma 3 minus sigma 1 by 2 mod should be less than equal to SYS by n or SYT by 2n. I am explaining the terms. Sigma 1, sigma 2, sigma 3 are the principal stresses. However, in biaxial state of stress, sigma 3 becomes 0. Okay, SYS is the yield strength of the material in shear, and SYT is the yield strength of the material in tension. And for Tresca's maximum shear stress theory, SYS is equal to SYT by 2. This is the relation as per Tresca's maximum shear stress theory. Okay, so the data given to us is that we have been given a biaxial state of stress. From this biaxial state of stress, we actually have to calculate first of all the principal stresses. Okay, so the principal stresses we can calculate by this formula that we know: sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy square. Okay, so put the values. This will be 80 plus 20 by 2 plus minus 80 minus 20 by 2 whole square plus this is 40. Tau xy is 40 square. So this becomes 50 plus minus 50, which is 100 comma 0. Sigma 1 is 100 and sigma 2 is 0. Okay, now put these values here, and whatever be the larger value among these three, equate it with the value on the right hand side. Okay, so the larger of sigma 1 is 100, sigma 2 is 0, so 100 upon 2 mod, comma sigma 2 is 0, sigma 3 is also 0, 0, comma sigma 3 minus sigma 1, that is sigma 3 is 0, sigma 1 is 100, minus 100 upon 2 mod is less than equal to what is given, shear strength or tensile strength. We have been given shear strength of the material, that is 100 megapascals, so use this term, that is 100 upon n. So the larger of these values, obviously these and these are, this value and this value is same, so 100 upon 2 is less than equal to 100 upon n, and for limiting case n becomes equal to 2. Okay, the next question is, Again we have a question on Tresca's theory and von Mises theory. See, I told you that these two theories are very important. Most of the questions are asked on these two theories only. So let's see this question. The principal stresses at a point inside a solid object. Okay, so we have directly been given the principal stresses in this case, and the yield strength of the material is 200 megapascal. The factor of safety calculated using maximum shear stress theory is NT, and the factor of safety calculated using von Mises theory is NV, and we have to find the relationship between the two. So according to Tresca theory is just, I've just done the question, same question, and the previous question was on Tresca's theory. So larger of sigma 1 minus sigma 2 by 2 comma sigma 2 minus sigma 3 by 2 mod sigma 3 minus sigma 1 by 2 mod less than equal to sys by n or syt by n. You know the terms because I have explained you the every term in the previous question. So sigma 3 is given as 0 megapascal, that is, it is a biaxial state of stress. Put the values. Sigma 1 is 100, sigma 2 is also 100, so this is 0 comma 100 minus 0, that is 100 by 2 mod, and sigma 3 minus sigma 1, that is again minus 100 by 2 mod less than equal to sys by n or syt by 2n. So the yield strength of the material is given, so we will be using this relation. So this is 200 by 2n. Okay, so when you solve this for limiting case n is equal to 2 from the Tresca's theory. Okay, now solve the same question by von Mises theory. Okay, so according to von Mises theory, we have the equation that is sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square is less than equal to 2 syt by n whole square. Okay, syt is the yield strength of the material in tension. Okay, so sigma 1 is 100, sigma 2 is 100, this becomes 0, plus sigma 2 is 100 minus 0 square plus 0 minus 100 square for the limiting case is equal to twice syt is 200 square upon n square. Solve it, n you will be getting as 2 again in this case. So this is nt and this is nv. Okay, and these two are equal. So the answer is option C. Okay, let's move on to the next question. In a structural member under fatigue loading, the minimum and maximum stresses developed at the critical point are 50 megapascal and 150 megapascal. This is sigma max, this is sigma minimum. The endurance, yield and the ultimate strengths of the material are given to you. The factor of safety using modified Goodman's criteria. Okay, so according to Goodman's criteria, we know that the equation is sigma mean, that is mean stress, upon sigma ut. Ut is the ultimate strength, whereas in Soderbergh's criteria here the term is yield strength. Okay, plus sigma v, that is variable stress, upon sigma e, that is endurance strength is equal to 1 by n. N is the factor of safety. So sigma ut is given to us, which is 400 megapascal. This is 400, and endurance strength is also given to us, that is 200 megapascal. This one we have to find sigma mean and sigma variable. Sigma mean is maximum stress plus minimum stress by 2, which is equal to sigma maximum is 150 plus 50 upon 2, that is 200 by 2 is 100 megapascal. And sigma variable is sigma max minus sigma minimum by 2. So that is 150 minus 50 upon 2, that is 50 megapascal. Okay, put all the values here. That is 100 upon 400 plus 50 upon 200 is equal to 1 by n. So this is 1 by 4, this is also 1 by 4, that becomes 1 by 2, so n is equal to 2. Okay, the option is D. Again a very simple question directly based on the formula. So let's move on to the next question. Okay, in a metal forming operation, when the material has just started yielding, the principal stresses are given. Okay, so the principal stresses are again given to you. Read ahead to find which theory you have to use to solve this question. Following von Mises criteria, the yield stresses. Okay, again a simple question and based on directly formula. So according to von Mises criterion on Mises, sigma 1 minus sigma 2 whole square plus sigma 3 sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square is less than equal to what? 2 SYT by n whole square. SYT is the yield strength in tension. Sigma 1, sigma 2, sigma 3 are the principal stresses that have been given to you, and n is the factor of safety. Okay, but here you have to find the yield stress, not the factor of safety, and nothing is given about factor of safety. So always take n is equal to 1 when nothing has been mentioned about the factor of safety. Okay, because factor of safety cannot be taken below 1. Okay, sigma 1 is 180 megapascal minus sigma 2 is minus 100, so take it with a negative sign. Minus of minus 100 whole square plus minus 100 whole square plus sigma 3 is again 0, 0 minus 180 whole square, and for limiting case it will be equal to twice of SYT square because n is equal to 1. So this is 280 square plus 100 square plus 180 square is equal to twice of SYT square. Okay, solve it. The yield strength in tension will be equal to 245.764 megapascal. So before this question they were asking to find the factor of safety, and in this question they have asked you to find the yield stress, so nothing much different. Okay, let's move on to the next question. Okay, so this question is again on maximum shear stress theory. So they have asked the question only on these two theories, so you see that these two theories are very important. Do not leave other theories as well, but prepare these two theories very properly. Okay, principal stresses at a point in a critical section of machine component are given, and in this case sigma 3 is also given. Okay, so the principal stresses are given to you. For the material of the component, the tensile yield strength is 200 megapascal. This is also given. According to the maximum shear stress theory, the factor of safety is. Okay, so according to the maximum shear stress theory, larger of sigma 1 minus sigma 2 by 2 mod sigma 2 minus sigma 3 by 2 mod sigma 3 minus sigma 1 by 2 mod should be less than equal to what? SYS up by n or SYT by 2n. Okay, this is the yield strength in shear, this is the yield strength in tension, and we have been given the tensile yield strength, so we'll be equating the left hand side, okay, with this value. So sigma 1 is 60 minus sigma 2 is 5 by 2, that is 55 by 2. I'm directly writing it as 55 by 2. 55 by 2 mod comma sigma 2 is 5 minus sigma 3 is 40, that is 5 minus of 40 by 2 mod sigma 3 minus sigma 1. Sigma 3 is minus 40 minus 60 by 2 mod, and the larger of these values For the limiting case, it is equal to syt upon 2n, that is 200 by 2n. Okay, so from these three values, the larger value is 100 by 2. Okay, because this is 45 by 2, this is 55 by 2, this is 100 by 2. So that is 100 by 2 is 50 is equal to 200 by 2n. So n is equal to 2. Okay, the option is B. So these were some of the problems based on theories of failure. I mean, almost all the problems were from the two theories, that is von Mises theory and Tresca's theory. So do prepare these theories thoroughly, and they are very important from the gate point of view. Thank you.